All right. Okay, here we go. We're only going to get started on this, so I'm going to call it 16A. All right, I need your attention now. It doesn't seem like anybody's listening to anything I'm saying. Don't want to call out your names or anything. Noah. All right, so we don't have a whole period because we took the quiz, so we'll just get started on this. I'll do like a front and a back to these notes. How's that? Yeah. All right, and it's called two-dimensional figures, and we'll call it 16A. Tomorrow we'll call it B. Hopefully we'll finish it up tomorrow, and we'll see how it goes. All right, so what we're going to do, basically, this whole lesson right here, it's not too much. At the very, very end, there's stuff that you can do some math, but this is all definitions, just learning new words, learning words that you probably have heard before, a lot of these, but maybe you didn't have a full understanding of what they meant, so maybe it'll help a little bit. So the first one, I bet everybody's heard of this, and it's a circle. Everybody knows a circle. All right, I'm going to write down the definition. It's the set of all points in a plane, a given distance, from a given point. That clears it all up, doesn't it? You're like, yeah, sure. I still don't have any idea what it means. And we call that point the center. The center. The center of the circle. All right, let me talk about that. I'm going to draw a circle. There we go. There's a circle. So it says, the set of all points in a plane, a given distance. I should put a given distance from a given point, and that given point is the center. So it means it's going to be the same distance. So it's all the points that are in a plane. And a plane just means it's in one surface. It's on one surface. So don't worry about that too much. But it's the set of all points, a given distance from a given point. What in the world does that mean? Well, it says that given point's called the center. And so we're going to draw a little point right there. That'll be the center. And the circle is basically all the points along here, okay? This is not on the circle, okay? So if I put a point right here, that's not actually on the circle. Where is the circle? It's that line that goes around, okay? It's that white curve line, I guess, if you want to call it, right? That goes around it. So what about a point inside? Oh, I just said it. What do we call a point right here? It's inside the circle or in the interior of the circle. And what about a point out here? The exterior of the circle, okay? What if I put a point right here? Where is that? It's on the circle, okay? You with me on that? So a lot of times people think of the circle being like, I don't know, like a cutout circle, cardboard cutout, right? Like a Frisbee, kind of like that, or a plate. And this is all part of the plate right here, but it's not part of the circle, right? This right here is the circle itself. Everybody got it? This point right here, what do we call that point right there? It's the center of the circle. So let's go through the definition again. It's a set of all points in a given plane from a given point called the center. So if I have a given distance, see that in the definition, the given distance, that'll be the given distance right there. I overlapped it a little bit. That's pretty good right there. See that line right there? That's the given distance. So if I take that, I wonder if I could do this. On this other program, I think I could do this. I don't think. Yeah, it's not going to. There's a way to keep that locked in right there and then like move this around. Let's just pretend. Who's calling me? Mr. Barry. In the middle of class. Hold on. Hey, Tom. Yeah, I can do that. It's no problem. I mean, I'm hanging around just do some work, but yeah, it's fine. I'm good. Okay. All right. See ya. Bye. All right. Sorry. Mr. Barry's got car problems and he needs a ride after school, or he might need a ride after school. So that's why I took the that's right. That's why I took the call. Normally I would not. All right, let's say we could lock this right here. And again, I bet you there is a way to do that. I'm just not going to take the time to figure it out right now. But what if I lock this in? This thing would go. This could go all around like this. Would you agree? And so the points that it makes right here all around is the circle. Okay, it's a given point. So everybody see the definition now? It's a set of all points in a plane, right? That flat surface, a given distance from a given point. So this is your given distance. This is your given point. And if I take that distance from that point and I go all the way around here, that makes a what? Makes a circle. Okay. So let's call this C for center, and we'll just call this point right there B. All right. Now you probably already know this. Should not be new to you, I would guess. But what do you? Yeah, that is a line segment. That's right. From a point to another point is a line segment. Wow, so many interruptions. That's fake out. All right. So this line segment right here is also called. It is a line segment. It's true. So if I was to name that line segment, what would I name it? Line segment, not line. Line segment CB. Why line segment? Well, it's not just because it doesn't have arrows. What does it have at the end? Right, 2 endpoints. That's right. It's got 2 endpoints. Okay, so that's a line segment. Notice this is how we write line segment. That tells you right there it starts and stops at C and B. We could also call it line segment what? BC. It would be the same exact thing. No big deal. Everybody good? Okay. We also have, so that's our line segment, but we also have a name for that line segment besides just line segment BC or CB. What is that? The radius, right? You've done that before, haven't you? The radius of a circle. All right, it goes from the center to any point. So it doesn't just have one radius. That's not the only radius this thing has. I could do this all day long, couldn't I? I could draw a whole bunch of what? Radiuses. Well, it's not really radiuses. The plural of radius is radii. 2 I's. Isn't that weird? We rarely have it. Do we have any other letters in our language that has 2 I's right next to each other? Can you think of anything else? Cacti? No, that would probably be one. No, igloo? It's not I-I-G. I don't know. I can't think of any off the top of my head. Anyway, so radii is the what? It's the plural of what? Radius. So we have 1 radius. We have 2 radii. That's how we say it. Okay, enough of that. I could keep doing this all day. There's a ton. How many radii are there in a circle? What is it? Unlimited? Okay, give me a word. An infinite number, right, of radii in one circle. Okay, that's good enough. I said we could call this line segment CB or BC. I would say this is the best way to call it. It's not the only thing, but I think it's the best way to name the radius. Why do you think that's better than BC? Any idea, Smart? It's it. You're going from the center out, okay? Now, you could write it line segment BC. That's fine. But I think it's a little bit better to write it CB because C is the center. You don't have to. I just think it looks a little bit nicer. Everybody good with that? Yeah, and we have a notation for circle. You know how we had a notation for angle, for line segment, for line, for, I don't know, we had some other things too. Didn't we? Ray, right? Angle, did I say angle? All right, we have that for this too. This is how we would name this. We always name a circle with 1 point, and what do you think that point is? It's the center, right? It's the center. What do we call the center of this circle? C. So I call it circle C. This is how we do circle. We make a circle, and they put a dot in the middle of it, okay? So that's the symbol for circle, all right? So we call it circle C. Is it a lowercase or an uppercase C? Why? Because it's a point, exactly. And points are always uppercase.
Is the CB line the one that comes like?
It goes from the center to any point outside here. So this right here is the radius. See that thing right there? That's the radius. Okay? Did that answer your question? Okay. Anybody else? Smart. We good? All right, let's move on. Here's a word, I don't know, it's not as common as circle, okay? You may have heard of it. It starts with a P. It's a polygon. Have you ever heard of that? It's got a prefix. You know what a prefix means? It's at the beginning of it, right? Poly. What word does that mean? Okay, multiple or many. We'll say many, right? More than one, right? So many. Now the gon right here, it technically means angles. So a polygon has many angles, all right? So I tell you what, I got me a nice little polygon right there. Look at that. Fancy, huh? All right. It's got many angles. Would you agree? So let's talk about this. This is a polygon. We're going to talk about more specific polygons than just this one. But for right now, let's just, I'm not going to write down the definition. It's just a little lengthy. But it's a simple closed curve that consists only of segments. Now, when it says curve, we always think rounded, don't we? All right. But that's not technically in geometry what it means. It's a simple closed curve. It's closed, which means there's no opening, right? It's all closed up. All right, that consists only of segments. Does this thing right here have only line segments? Yes. All right, and it says each of these line segments has a name, and we call that a side. All right, so every single one of these is a side. How many sides does this particular one have? 1, 2, 3, 4, 5, 6. Yep, so this is a six-sided polygon. And it actually has its own name. We'll talk about that a little bit. Now, all the octagon was 6? Yeah, very good. So you have learned this before. I figured you had. All right. That's all right. We're going to get to that. All right. Do you see where these line segments come together? They come together at a point right there. And it forms an angle, doesn't it? So what do you think that point's called? Something we've talked about already. It's a vertex. We call that the vertex. Nope. Vertices. Okay, that's the plural. Oops. Vertices. Verti, that would sound cool, but it's vertices. Okay? So that's the plural of vertex. So if there's 6 sides, how many vertices are there? 6. Okay, there's just as many vertices or angles, right? There's also how many angles in here? There's 6 angles. 1, 2, 3, 4, 5, 6. All right. Now, I drew this one so that all the sides are equal to each other, all the angles are equal to each other. That's not always true, but the further we go with this stuff, we're going to do a lot more stuff, probably not in this chapter, but in another chapter, we're going to do a lot more stuff with this, and we call this a regular polygon. Not just this one oops, why did I put R? Polygon. Now, when it's regular, 2 things are the same. It has the same, I shouldn't say it's the same. I should say they have equal. Right. Equal angles and equal sides. Okay? All right, so the sides are all the same and all the angles are the same. If it's a regular polygon, we're going to be doing a lot more with that later on in the book. I don't know what chapter. I can't keep all the chapters straight, but sometime in the future we will be doing stuff with a lot of regular polygons. All right, and we're going to be doing some math and all that good stuff. Okay, we're going to be doing kind of complicated stuff. All right, but right now we're just learning vocab. That's all we're learning. We're just learning what the names of these things are. Okay. What if, now I can't, can I? I don't think I can draw it on this program, but
The equal angles and equal sides
It's regular, yeah. Okay. Now let's do this. Now both of these, actually I should have saved this for like a little bit later. I should have done this next thing first. I'm looking at my notes. I just kind of got ahead of myself. But what if you have one that just has, what if you have one that just has equal, we'll go sides first on this, okay? Equal sides. So if you have a polygon with equal sides, so all the sides, I don't know how many sides you have, but all the sides are equal, but not necessarily the angles are equal. You could have that situation. I don't know if I could really draw that for you. I didn't draw it on my notes. But if you had something that had all equal sides, a diamond, okay, that, well, yeah, you might be able to have something like that, okay, and all the angles are not equal to each other, all right? But if you have that, we call that, let's write it right here. We call it equilateral. E-Q-U-I, that means equal, all right? You kind of see that word in there, don't you, a little bit? Equilateral, L-A-T-E-R-A-L. Equilateral, the word lateral means sides, okay? I don't know if you guys play basketball or not, but there's a lot of drills where you move from side to side, okay? They call that the lateral drill, all right? In football, if you lateral the football, that means you're throwing it off to the side, all right? So lateral is used in a lot of different places, but lateral means sides. So if it has equal sides, it's called what? Equilateral. So let's take a wild guess what it's called if you have equal angles. If just the angles are equal to each other and not the sides, we would call that what do you think? Angular. All right? Equiangular. So if you have equal angles, it's called equiangular. Now, if you have both of those things that are true, we've already talked about it, if both of these things are true, it's equilateral and it's equiangular, then we call it what? Regular. That's right. We call it a regular polygon. Like I said, I got ahead of myself a little bit up here, but that's okay. All right, well, let's do this. This will be the last thing we do. When's this over? 10 after?
Yeah.
Okay. I probably say that on every single lesson I teach. When's this over? Let's do this. We're going to do a thing called classifying these polygons. We're going to name some special polygons, basically is what it's saying, okay? And I'm going to name them by the sides that they have, how many sides they have, all right? So I'm going to name it by how many sides. Now, can I have a polygon with two sides?
Yeah.
Why not?
How is it going to make a shape? I mean,
It's not going to make a shape, right? It's going to be open, isn't it? Remember the definition? I didn't write it down, but I said the definition was a closed figure, right? So if I only have two sides, there's no way I can close it in,
they're not curved.
right? Well, remember I said it says curved, and we think of curved as being rounded, but in geometry, a curve doesn't necessarily mean rounded, all right? Right, and they got to be made of straight segments, so it can't be curved anyway. All right, but anyway, can you have two sides? No. What's the smallest number of sides you can have in order to have a polygon? 3 sides, okay? 3 sides. And we have a name for it. Rectangle? Were you going to say rectangle? Triangle. Yeah, we all know that. That's easy. That'd be the easiest one out of all of them. All right, so if you have 3 sides, it doesn't matter if they're all equal. They don't have to all be equal to each other in length. Okay, as long as you have 3 sides and they're closed in, right? There's no gaps in it. We call that a triangle. All right, believe me, we're going to do a ton of stuff with triangles. Lots and lots of triangles. All right, so get ready for that. All right, what do you have 4 sides? A lot of people would say rectangle or square, but to be general. To be very general, we're going to call it a quad. Why quad? Because that means 4. Okay, R-I, and then what? Lateral. Okay. Triangle means what? 3 angles. But if it's got 3 angles, then it's going to have 3 sides. Okay. Quadrilateral, how many angles is it going to have? Right. Yeah. Every time you have this certain number of sides, the number of angles is going to be exactly the same. Okay. Let's go some more. Number 5 sides. It's a big old building in Washington, D.C. And actually, yesterday, I didn't even mention it yesterday, and I should have. I usually do. What was the date yesterday? Yeah, it was September 11th, okay? You guys were not alive for it, but I was very much alive. I was at a different school teaching, and man, it's one of those days. Like when I was a kid, everybody was like, "Oh, I remember the day John F. Kennedy got shot. He was our president, right?" And that was in '62, I believe, and I was born in '60. Why are we talking? I'm telling a story. So he was shot in '62. I was born in '65, so obviously I didn't remember it. But that's what people said. Oh, I remember the day. I remember exactly what I was doing when John F. Kennedy got shot. You know, I'm like, wow, I don't have any days like that. But then, and I wish I didn't have any days like that, to tell you the truth. But 9/11 happened, and that's one of those days that just sticks with you the rest of your life. I can tell you everything I was doing that day. It was crazy. But I'm not going to talk about that now. So why did I talk about that? Because it wasn't just the Twin Towers that got knocked down. You've probably seen videos of that, right? It wasn't just that. They also went into D.C. and a plane crashed into another building. What building was that? That was the Pentagon, okay? And why do they call it the Pentagon? Just because it's a cool name? Because it's got 5 sides. And it's actually a regular pentagon, all right? It's a regular pentagon. So anyway, let's do that. I'm going to stop my stories. All right, we already talked about this, and this is, remember that first polygon I drew? There were 6 sides to it, and you guys said already that's a hexagon. Okay? So again, this is all vocabulary. Now 7's kind of a weird one. 7 we don't use very often. Hexagon you see a lot. Pentagon, triangle, quadrilateral. You see those a lot. This next one, you don't really refer to it too much, but it depends what book also is talking about it. They call it a septagon. The first time I taught geometry, I taught it out of this book, and they call it a 7gon. I was like, I like that. That's a lot easier. Just call it a 7gon, a 6gon, a 5gon. You know, that'd be a lot easier, wouldn't it?
Isn't that what they call it when it's like
47gon, right. Yeah, we run out of names. You can't name every single polygon. But these are special ones. Smaller one. Yeah, this is definitely. Now, this is something that you probably see every single day of your life. What's an octagon? What's an octagon you probably see every single... Yeah, stop sign. And a stop sign is also a regular... Listen. A stop sign is also a regular polygon. All right? So you could say, if your mom's driving you or something, you say, Mom, slow down. We're coming up to a regular octagon here. All right? And then they'll probably slap you and say, nerd. and go on. I don't know. All right. This is another one we don't use all that often, but they call it a non-agon. I don't know where they get these prefixes from. Probably the Latin is my guess. It's probably where a lot of these prefixes come from. 10's pretty popular. How many years is a 10-year span? What do we call that? A century? A decade. It's a decade. So deca is 10. Okay, so we call this a decagon. Then this one, I don't know if I've ever heard this. We're going to go to 12. Okay, they call this a hen decagon. Again, I don't know where they get that prefix from. Hen. Maybe. 1 plus 10. Could be. And then we got one more. This is the last one. We have a dodecagon. Doe. Doe, a deer, a female deer. Do you know that song? Doe. Dec. If I could spell here. Okay, all right. I just asked if you knew it. I didn't ask you to sing it. All right, and then after that, like I said, after that, we kind of run out of names, all right? And so they do this. What if there was n number of sides? What do you think you're going to call it? An n-gon. All right, so that means if you have 27 sides, what are you going to call it? 27-gon. Or I would just say a polygon with 27 sides. That's basically what I would call it, okay? But these are special ones, okay? And we need to know them because every once in a while they're going to refer to it. They're going to say, okay, you got a decagon and each side is this much. You know, what are the angles of that decagon or something like that, okay? So it is important to know a lot of these. Some of these we don't use that often. Again, here are the biggies. The biggies, triangle, quadrilateral, that's huge. Pentagon you use a lot. Hexagon you use a lot. Octagon, decagon. those are the ones that you use probably more than any others. All right, so that's what that is. Now, I could have, if I had more time, watch this. If I click this, watch. There's a triangle, right? And then if I click this, I can make 4 sides. There's a, what?
A square.
100? All right. Oops, wait a minute. Wrong thing.
This is gonna be crazy.
100?
Yeah.
All right, 100. What do you think it's going to look like?
I don't know yet.
Very good. That's what I was wanting to hear. It's going to look really close to a circle. So watch. Look at that. It almost 50.
Yeah. I see tiny little.
Can you do 75?
Let's do 50.
No, you're getting watermelon.
So like if you blew it up, it gets a little bit. Let's see.
This is like
What's that?
20.
20? 40. Oh, see, there's the dots when I hit that button right there. Where are you going? The bell didn't ring. I don't know why you're standing up. No, it's not. Bell didn't ring. We're not done. Whoops. What do we want? 20? Let's see what 20 looks like. Whoops. There we go. See, now you start seeing the straight edges to it, okay? Guys, what's going on? Why are we throwing stuff?
Wait, can you do
Okay.
10?
10?
That's
There's 10. All right. All right, there you go. We'll finish this tomorrow. Give you homework tomorrow.